Hello and welcome back everyone. Into this video, we're going to talk about advanced controllers. In the previous videos, we talked about controllers for general use cases. In this video, I'm going to talk about advanced controllers, which are going to be much more sophisticated and very hard to implement. Of course, they cannot be implemented on Arduino and robotics is directly. So you might need to work on, some other high performance hardware like Raspberry Pi or like a computer or something. But that being aside, I want you all to learn about it because it's very important, because I want to make sure that you are keeping up with the trend. And for that, this is a very effective topic. And without any further ado, let's actually dive into it and understand what I'm going to talk about and how these are important for you as well. Okay, so we are back with the chapter, and let's move ahead. And then we say definition, of advanced controllers are going to be about specialization controllers that provide unique capabilities to robotic systems. Essentially speaking, we are talking about that all of these controllers are going to be very unique, and all of these controllers are going to be very important for robots to have a proper capability. Okay, if the robot is not having capabilities of making sure that these robots are working, then they are not really useful. Okay, so since they are pretty effective and they're quite complex, but they make the robotic system much more advanced and much more reliable. So these are very important as well. Advanced controllers are designed to perform tasks that are difficult or impossible to accomplish with standard controllers. Okay, we talked about similar things with sensors as well, but this time we're talking about controllers. There's several type of advanced robotics controllers in robotics, including adaptive controllers. Very important, very. I mean, I can't emphasize on how important these are. Okay, and when you say adaptive controllers can adjust their parameters based on changes in robotics behavior and environment. Let me actually come back to the camera. Yeah. So adaptive controllers so far help you in so many ways. Okay. Whenever you see a robot which is changing speed, or whenever you see even a car, okay, and I think these is a lot of cars actually have this feature. It's known as adaptive cruise control, the same adaptive controller, but implemented on a car. Essentially speaking, what happens is whenever there is a car in the front, the car or which is having an adaptive cruise control will automatically slow down and will make sure that it's not going to hit the car, and then it adjusts its speed according to what is going to happen or what the car in the front is doing. Very effective and very reliable as well. I can't even tell you how improved these controllers are these days. They're so reliable. I think 99.9% of accuracy. Okay, that 0.1% is simply because if the controller is not powered or some problem happens. But 99.9% of the time, all of these adaptive controllers are tuned so properly that they can give you extremely good results. Very important. Okay, so adaptive controllers. That's one. Then we move on to the definition of adaptive controllers are commonly used in application where the robot's behavior may change over time. Okay. Now, when I say change over time, it means, effectively right now the robot is doing something, and after a while it's going to do something else. At that time, you use something known as adaptive controllers. Then you have sliding mode controllers, SMC. Sliding mode controllers are used in non-linear control laws to provide robust and stable control of the robot. Okay, I'll tell you about it, I think, with the definition. So SMC controllers are used commonly in application where the robot might experience disturbances or uncertainties. Okay. Now, I'll tell you what happens is that they are effectively present in robotics or in any sort of situation where the results are not even defined. Okay. And you have no idea what is going to happen. Like, let's say you take the example of a rocket ship. Okay. Whenever a rocket ship is flying up in the sky, okay, possibly chances are the people over there don't really know what is going to happen with that rocket ship. If something else is going to explode or something, this is going to happen. There are sometimes there are extremely critical parts which need extremely critical reliability, like the cockpit of the rocket. Okay, so let's say there are 5 people who are traveling inside the rocket, and the rocket has some problems. In that case, the first priority would be to save all the people who are there on the rocket. Correct, right? This is possible because if you have a SMC or sliding mode controller, these controllers will prioritize, which part of the process is on the top and which part of the process effectively is going to be used. And this whole hypothesis of having a controller that can take care of all of these things is only possible because of we have SMC, sliding mode controller. Very reliable, okay, extremely reliable, especially for spacecrafts and mission. Very difficult to implement as well, but you should know about this so that you know what SMCs are. Coming back, let's move on to the next one. then we can see neural network controllers, or NNC, or NNN actually. Okay, so neural network controllers use AI, okay, artificial neural network, to learn the controller behavior of the robot based on past experience. Of course, use are commonly used in application where the robot behavior is complex and difficult to model. So, of course, AI is taking over so many things, and this has to be one of it, where the controllers or the controls of the situation or the robot happens to be dynamically adjusted depending on what the robot is doing and what all inputs of the sensors the robot is getting. And this allows for a very dynamic relation to happen. Okay, that a lot of times these dynamic situation or dynamic relation will allow you to make sure that your robot is having the capability of predicting and doing things which you can't even imagine. Okay, so that's what the good part is. Then you move on to the importance of advanced controllers. Why do we even need such controllers? So advanced controllers are important in robotics because they provide unique capabilities that are difficult or impossible to achieve with standard controllers. Of course, advanced controllers enable robotic system to perform tasks in a more efficient, precise, and flexible manner. So all of these are very important words: precise, efficient, precise, and flexible manner. If you don't have these, then it's a problem. Okay. Some of the examples of advanced robotics and advanced controls in robotics include adaptive controllers. We talked about it. Okay. Then you have the SMC, sliding mode controller. Then you have the neural network controllers. Okay. This is just a recap. In conclusion, all of these controllers specialize in providing a unique capability of the system, which effectively allows the system to take decisions. Understanding different type of advanced controllers is essential for designing and building effective robotic system. And we are done. Before I say we are done, we have to understand a couple of things. All of these advanced controllers which I talked about are essentially applicable once you have the base controllers. Okay, so the previous video that we talked about the basic controllers, if those systems are not there, then implementing these are going to be much more challenging, because these controllers actually have certain criteria to even work properly. Okay, like let's say you take the example of SMC, okay, sliding mode controller. That controller won't work if you don't have a sensor filter. Okay, so if the data from the sensor is not getting filtered and you apply SMC directly, chance of that controller failing is really high. Okay, the reason is the controllers actually have certain dependency because of the extreme complexity. Okay, see, after a certain point in a controller process, okay, you cannot process raw data and raw information all the time. You need a certain standard of information to be there always, so that you can move all the way up from there. Okay, if you don't have that certain base level of information, chances of the controller failing are going to be increasing all the time you're going to do an iteration. Okay, what does that mean? Let's say one time you are running the robot and something happens. Okay, the SMC controller understood what happened, and is going to help you predict that it doesn't really happen next time. Now all of these patterns need a lot of processing to happen, and those processing can only happen if the SMC can focus only on the pure data which is there from the sensor. So usually when you're using SMC or any of sort of like advanced controller, you would want a filter, okay, and like a couple of more filters to be applied onto the sensor data, so that you can clear off all of these things, and you can achieve a much more effective output at the end. Okay, and that makes it like these controllers quite robust. But I hope you understood what this was all about. I'll see you all in the next one. Till then, happy learning and peace.